So actually, we know a lot about the early stages of auditory processing. We know that there are sound waves. They are propagated down into a structure in your ear called the cochlea. Within that structure, there are neurons that are exquisitely sensitive to minute changes in pressure. They're sensitive to those changes at different frequencies. So actually what your cochlea does is it acts as what's called a spectral analyzer. So there are some neurons that are sensitive to low frequency sounds, and other neurons that are sensitive to middle frequency, and other neurons that are sensitive to high frequency. And each one of those is coded separately along a set of nerve fibers. Then they're passed through a bunch of stages in your auditory system before they get to your cortex. So the last stage, so I'll say that what's interesting is that the stages of processing a sound are incredibly different, as you might imagine, from the stages of processing a visual scene. So those stages that I just told you are designed for processing physical vibrations between the ranges in a human of 20 hertz to 20 kilohertz. We have eyes that aren't responsible for transducing sound vibrations, but rather light. And the structure of the retina is also well understood. There are photoreceptors that pick up photons and transmit those signals. But what's interesting is that once those signals get processed, or if you like, pre-processed, they end up in structures that now look remarkably similar. A structure called the thalamus. And there's a part of the thalamus that receives input from the auditory system, another part of the thalamus that receives input from the visual system, from the retina, and then after it gets to the thalamus, it goes to the cortex, and within the cortex, the signals now look very similar. And so what seems to be the case is that there's this preprocessor on the auditory side, on the visual side, and actually all your sensory modalities that's highly specialized for the kind of sensory input we have, but then it converts it into sort of a standard form that gets passed up to the cortex. So what we actually believe is that the mechanisms of auditory attention are actually not probably fundamentally different from the mechanisms of any other kind of attention, including visual attention.